In this lesson will cover families of a quadratic function. The learning goal is to understand what a family of curves is and determine the specific members of a family given roots or the vertex. Your success criteria is to determine if two or more functions are part of the same family by analyzing the roots or vertex. So families of a quadratic function all share a common characteristic, for example, the same vertex or the same x-intercepts. So in this case here, on the left we have three functions that all share the same vertex, so they're all part of the same family. Whereas on the right we have three functions where they don't share the same vertex, but they do share the same roots. Which that means that for each quadratic function, it can be part of two families, one for vertex and one for its roots. So given the function f of x equals negative 3 x minus 1 squared plus 4, we want to determine another quadratic equation that belongs to the same family. So we know that family members share the same vertex or same roots. This is vertex form, so we want one of the same vertex. The vertex here is 1, 4. So we need another equation with the same vertex, but a different a value. So another family member will be, for instance, g of x equals, and we pick any number for a, literally anything. Let's do negative 2 for now. We have x minus 1 squared plus 4. So we know it's a family member because it has the same vertex. Its a value is different. Now a can literally be anything. It can be negative 1.5. It can be 15 over 4. It can be 2000.7. Anything. As long as it shares the same a value, it is a family member. Now that leads into the general equation. The general equation for a family of quadratic equations is the equation that all equations of the family are based on. Now this can take either the vertex form or factored form. So remember, vertex form is x minus a squared plus k, and factored form is x minus r, x minus s. In both these forms, the only value that can change is the a value. Vertex form requires h and k to be the same, and factored form needs r and s to be the same for it to be part of the same family. So for example, given the function f of x equals negative 3 x minus 1 squared plus 4, we're now going to determine the general equation for the family of quadratic functions with the same vertex. So we know our vertex is 1, 4 as above. So our general equation would be f of x equals, and instead of writing negative 3, we always write, or a value, we write a itself for the general equation. So a, and then we have x minus 1 squared plus 4. So that's our general equation. The exact equation from a family of quadratic equations is where the a value is known. So up here, this is an exact equation, and this was our general equation down below. To determine any exact equation, we need to substitute a known point in the general equation to solve for a. The reason why I have to use a point is that gives us the y and x values, and that allows us to have every variable except for the a value, which we can then solve for. So given a function, the same function as above actually, we'll determine the exact equation of the function that has the same vertex passing through negative 3, 12. So we know our general equation here is f of x equals a x minus 1 squared plus 4. And our point here, our exact equation here, our exact is using the point negative 3, 12. So f of x, which is y, is going to be 12. So we have 12 equals. A is unknown. X is negative 3, so we have negative 3. Minus 1 squared plus 4, and then we're just going to solve for a. So we're going to subtract from both sides. We get 8 equals a, and then we have negative 3 minus 1, that's negative 4 squared, and then we have 8 equals negative 4 squared, 16, 16a. Remember, we want the quotient first, and then divide both sides by 16. 8 over 16 can be simplified down to 1/2, or 0.5. So a, in this case, is 1/2. So our family member that goes to the point negative 3, 12 is g of x equals 1/2 x minus 1 squared plus 4. That's it. In the next example, we have our roots. But in this case, roots are a little bit different here. So we want to determine the general equation of the family of quadratic equations that has roots at 1 minus root 2 and 1 plus root 2. Then determine the specific family member that passes through the point 2, 4. So our general equation, which we need first, we do have its roots. That means we're using factor form. So our general equation is going to be, we'll use f of x again. So f of x equals a, and we have x minus, we have our first root with 1 minus root 2. We need that in brackets because it's more than one value. So 1 minus root 2. And then we have x minus the 1 plus root 2. And then we have our exact equation. Use a point 2, 4. So f of x is 4. A, and then x is 2, so we have 2 minus 1 minus root 2. This is where it gets rather tedious. There's a lot to do here. Well, I need 2 brackets there. And then we have another 2 minus 1 plus root 2. And now we can go ahead and solve for a. So we have 4 equals a, and we have to go through these brackets. It's 2 minus 1. That's 1, so that's 1, and then minus, we're going to subtract this negative root 2, or we can distribute the negative 1 in, so that's 1 plus root 2 here. In another bracket, we have 2 minus 1, that's our 1, and then subtracting the root 2, that's minus root 2. In this case, we could use a calculator and get some irrational decimals, but we don't want to do that. If we're working with roots, we want to keep them or use the roots themselves as much as possible. So we're actually going to FOIL here, and you'll see why we do that in a minute. When you have roots in this particular case, more than commonly, you're going to actually get rid of them. So just to the side here, to see what it looks like, we would have 1 plus root 2. Whoops, that's not a 2. Then we have 1 minus root 2. If we FOIL, we have 1 times 1, that's 1. 1 times negative root 2, that's minus root 2. We have root 2 times 1, that's plus root 2. That's where they're going to disappear. And then we have root 2 times negative root 2. Remember, 2 roots that multiply each other. So if we have root x times root x, it's equal to x itself. It's equal to what's inside. So positive times negative is negative, and then root 2 times root 2 is then 2. So all of this is end up, these are going to cancel. So we have 1 minus 2, and that would give us negative 1. So off to the side, we put it all back in. We have then negative 1a. I mean, I could have put this down here, but I want to put it off to the side. And then we just divide both sides by negative 1. So a is equal to negative 4. And then we can then make our exact equation. So we'll say g of x again. G of x is equal to negative 4. And then we'd have all of this again. We'd have x minus 1 minus root 2. And then we have x minus 1 plus root 2. So when you're dealing with these kinds of roots, you do have to, again, remember, put them in brackets when you substitute. And as you're moving through the process of solving for a in these kinds of situations, very commonly you're going to cancel them out and end up with no roots. So don't use a calculator for this. Actually go through the process of expanding and simplifying, and you'll get a nice clean answer.